both us and the presenters, and a good number of people. Welcome everybody again. We are very from very diverse countries, and also people are wake up very early this morning, or are wake at night, I don't know. But anyway, let's start with some practical instruction for the presenters first, and then we will discuss all the papers that are very interesting. So as you may know, you have 10 minutes for your speech, and then we will allocate around 5 minutes for a question and answer or a short discussion from my colleagues. You can write directly in the chat your question, if any, or better if you would like to intervene by opening your mic and camera. I will be very narrow for ensuring that the time is respected, also because we have time, but not too much to be too much longer. So please forgive me if I will stop you or advise you 1 minute before the end of your 10 minutes time. But I think that this would be the best way to work today. Okay, so I think that we can start immediately if you don't have any urgent question to ask. So I can invite the first presenter, Matteo Seraceni from Era Luce.
Good morning, everyone.
Hello, Matteo. His speech is about human-centric outdoor public lighting. Matteo,
yeah. I will share my screen.
Yes.
Okay, this one.
Great.
Okay, I need to switch. Okay, tell me if you see the right way the presentation.
Yes, it's perfect.
Okay, let's start. Okay, thank you, Elisa. My name is Matteo Seraceni, and I'm looking forward to talking with you about how we can balance common outdoor lighting requirements, for example, road lighting standards or light pollution limitations, and the needs for a more human-centered outdoor lighting. I am the head of engineering for Era Luce, an Italian company that builds and manages public and artistic lighting systems, and also smart services for cities. We manage more than 500,000 luminaires, serving 170 municipalities. Needless to say, every day we struggle so hard to provide good lighting for people, to reduce energy consumptions and light pollution, and to drive innovation and business value. We had the opportunity to take part as main technical consultant for Italian Ministry of Environment in defining the green public procurement for public lighting. Today, I will discuss the assumptions that drove us and the conclusions that we have reached in that regulatory table. And let's start with road lighting. We have 4 main purposes. First, provide visual conditions so that all users can perform the needed driving tasks. 2, allow pedestrians to see hazards. And 3rd, allow pedestrians to recognize other pedestrian face. And 4th, improve the appearance of the environment. And even 3 out of 4 points are directly connected with visual perception of surroundings. European standards and current practice aims to fulfill only minimum ground illuminance and the uniformity of road or pavement surface. Let's make an example. I show you 3 different lighting systems that could provide the same amount of ground luminance. The first is an old-fashioned luminance that could provide a good amount of light almost anywhere. Yet they were highly energy consuming and they provide a lot of light pollution. The second is a modern LED street lights that could provide a specific well-lit area while avoiding light trespass and wasting flags outside the area to be lit. Nevertheless, with one-side poles arrangement and full cut-off luminaires for broad street, it's almost impossible to achieve good vertical illuminance on the opposite sidewalks. The same with low mounting fixtures, such as pole top luminaires for garden or pedestrian areas that even a lower distance could not achieve good vertical illuminance. Not to mention surroundings. It is not uncommon to see good lit roads, but with sidewalks poorly lit, where it's almost impossible to recognize other faces. But we'll get back to it later. And about light pollution, nowadays light pollution has widened its meaning by including effects as sky glow, light trespass, over illumination and glare, but also the adverse effects on wildlife and human health. Common guidelines for lowering light pollution could be summarized in 4 points. 1, reduce upward luminous flux. 2, use the lowest possible intensity to satisfy minimum requirements for every area. 3, avoid cold white light. And 4, adapt exterior lighting to times of use. In some ways, point 1 and 2 have a lot in common with what I was saying before. I would like to stress the fact that these statements must be contextualized. I like to use as example a very famous illustration to demonstrate that the definition of useful light may vary. For the man in the picture, having a dark surrounding would be good while on his private property, but in a public space, we could perceive the lack of light outside of the road as unacceptable and mostly wrong. Indeed, in urban environments, it might be desirable to use some light provided by the road lighting to enhance building facades or to provide vertical luminance for social interaction. In these cases, the luminous flux onto the facade on people has to be regarded as useful light, although it might lower the energy efficiency on the road lighting as such. So it's good using the lowest possible intensity to satisfy minimum requirements. But we must first agree about what we mean by minimum requirements. And before moving on to point 3, I would like to discuss point 4. We can adapt exterior lighting in relation to traffic volume or for pedestrian areas to time or other parameters. Switching off lighting or dimming off lighting when not needed could nip the problem in the bud. With dynamic lighting system, we could easily reduce light pollution as well as energy consumption without diminishing the functionality of outdoor lighting. But smart lighting systems are much more expensive than traditional systems, and we might need a major effort to improve our data-driven services for cities. About cold white light. Many articles claim that light sources with higher correlated color temperature may have a great impact on starry sky. Again, before saying anything, we need to define who are seeing what and why, and also where this observer is placed. Inside the city, maybe we are looking for something different than seeing a starry sky. And we can assume that direct light is just a small part of overall light pollution. So we could be a little more permissive to make sure we can provide the right light for city beautification and nighttime activity. The farther we go from the city center, the more we could be interested in stargazing. Also, prevalent scotopic vision and the lack of obstacle in light paths suggest that we lower the correlated color temperature and the upper flux at most. And I want to make a little digression about circadian light. And if we consider only public lighting with corneal illuminance mostly below 5 lux, the potential circadian effects are very low. Moreover, color temperature could be a bad estimator because we might experience spectral opponency between temperature of 3000 and 4000 Kelvin for LED source. But, I mean, it's a huge but, we should also consider that many times private lighting are primarily responsible for light pollution and can also ruin a well-crafted landscape, such as, for example, in cultural heritage areas. So limiting only public lighting could be highly ineffective without addressing private lighting. In recent years, the human and social dimension of urban landscape has become a new theme of interest in both research and design practice in the lighting domain. On the right, you can appreciate a framework of human and social lighting criteria from a great book from Daria Kashani about this topic, and I highly suggest everyone to read it. In comparison to energy, technical, and economic issues, the social value of urban lighting is rarely considered when policy decisions are made. Nevertheless, I have listed some of the best practices regarding urban public lighting. I want to underline two of them. First, we need new and better metrics for public lighting because we need to evaluate for real what is the right light for people. And second, we need to rediscover the power of the dark in the city with a new approach of lighting design and the extensive use of dynamic light. So this is what we have done. Instead of a long list of rules, we focused only on 2 points. First, energy efficiency of both light fixtures and lighting systems, all powered up by dynamic lighting. And it works just like the energy level for home appliances or buildings. For each application, street, parking, and so on, the energy density is compared to a baseline to define the letter of the energy class. And second, for lighting zone based on European town planning scheme, for every correspondence between zones and applications that I mentioned before, we have defined a maximum applied flux. And this brings me to the end of my presentation. In conclusion, we need a new approach to urban lighting focused on people. We need dynamic lighting system. We need to adopt new criteria that should aim at decreasing energy consumption and lighting pollution without limiting the design option available. And Italian green public procurement could provide an energy labeling system and also a simple yet effective upward light limitations that can ensure the lowest level of light pollution and at the same time can allow the right vertical luminance where needed. And finally, we need to regulate both private and public outdoor lighting systems. So that's all. Thank you for your time, and I leave you also with some reference.
Thank you, Matteo. You have been perfect in timing and also for in content.
Thank you, Elisa.
Any question or comment, Mark?
Yes, no, I mean, well, first, thank you very much, Matteo, because you've been very dense and you've kept it to 10 minutes sharp, which is incredible considering the density of what you've just said. So I was lucky to be able to read your abstract, which was also quite detailed. So actually, I prepared some questions, but seeing your presentation, you also already kind of answered some of them. So that's really good. Perhaps I just want to mention a few things, and you're quite right in saying that the social dimension of urban lighting and lightscape and nightscapes is not that frequently talked about. And yeah, I think that's very important to share. And yeah, perhaps.
Yeah, I think this could be a great topic for the work we are going to do, because so less about this topic, I think, because if we think about light, well, light is for people. Okay, we we switch on light just for people, not for a monument that is applied just by itself. Okay, and so I was ever wonder why are doing such thing, just like a calculation of road lighting, when maybe in that road there is no one, but on sidewalk or on pavement around the road there are a lot of people, but the lights are only on the road and not on the sidewalks, and for me it's crazy.
Yeah. So, but I mean, you've touched upon a lot of challenges and the complexity of this, because yeah, for the light pollution part, of course, it's very, very important, and there are new norms and new legislations. Thinking especially in France, for example, very, very strict legislation that everybody was talking about. It was starting to get in application now last year. So one of my big questions is around and you touched upon that, the real big issue is private lighting, I think, because I'm not aware of a lot of legislation and recommendations. Yes, but legislations is much more complicated. In the public realm, I think the private lighting has been demonstrated to be very very important in terms of the light flux and the pollution that it might cause. So, my question would be, how to have an impact on private stakeholders, how to work with private stakeholders. And in Italy, have you found, some very interesting ways to do that?
Well, in Italy, we have regional legislation about private lighting that should not hazard or should not increase light pollution, but it's very difficult to applicate it, because is a legislation without any punishment. So it's just more like a suggestion, and I'm sure is not working as they ought to be, but I think is already something. But I think for private sector, the most of it can come from making people aware of this problem, and the more you speak about it, the more people understand it, and maybe they would try themselves to limit the upper flux or something, over illumination or something like that, because I think that up to now people don't really understand why they have to limit the flux of the light. They think that okay, if I switch off my light or dim them off, there could be a lack of security, for example, outside my house or my I don't know, production plant, something like that. And I think that we need, and I think this group could be effective also in that way. We could make more aware people of this problem, and try to, how to say, nudge them, not to push them with a law. I think for private sector, the better is to try to nudge people, not to try to pull them to do something.
Yeah. So perhaps more cooperation and
sure.
not light policing too much. Okay, we have one person with your hand up. I see. So don't hesitate. I mean, there's perhaps one or two questions per speaker. So go ahead. I think one question is good, and then we'll Elisa.
Yeah. Siak, okay.
Please go ahead.
Yeah, thanks a lot for this talk. So you mentioned the dynamics of lighting systems throughout your talk. So I was wondering, are you aiming for an approach that sensors tell if road traffic is approaching and turn on? Or would you say it's better perhaps to integrate, if there hasn't been traffic for a certain amount of time, we turn off? Because I can imagine if you live near such a road, actually the change in light can be a polluting factor in itself. So any thoughts on this?
Okay, Thank you, Jacques. It's an interesting question because, yeah, sure. I think that, as I said before, dynamic lighting system could be could have a great impact of lowering light pollution and over illumination, but they came with a cost. And so if we try to put many sensors just to dim light, maybe this could be ineffective because they cost too much just to dim light. And so I think that we need a whole kind of sensor all around the city that could provide not only the vehicle, the traffic, the traffic situation of the road of the city, but also maybe where people are in some moments inside the city. So you make just like a connection, a network of sensor around the city to see where people are and where are they going to, and then you can plug some ways the light on this network and assess the dim of the single light according to this network. So it's just providing a virtual city where you can manage where people are and where I'm going to, and then put back on the real city, on the real light on the city, and they can dim only where there aren't people in some place or after hour where the system could, I don't know, maybe with some kind of artificial intelligence have a provision, have a foresight of where people are going to, or at the time that people is not in that place in the past, so is not in the place maybe today. And you can have some kind of assessment all around the city, but I think this sensor is not only made for lighting. Maybe they can be made also for traffic lights or to provide guidance to vehicle with, I mean, with how is called the communication between vehicle to vehicle and V2X communication, something like that in the future. So maybe you can tell the network can tell you not going that way because there could be a traffic jam going another way. And so with the light, okay, maybe the light can direct you to another path if you see traffic jam above you. And so I think it could be interesting in the future to see how all this system can match together to give us better lighting. And but we must also need the dynamic lighting to be this kind of thing. So we must think now about putting dynamic light inside our city, and then for the future have something that could be worth the way.
Okay, thank you very much.
I'm not sure. I was maybe so confusing, but
no, it's okay. I think we need to move on now. Thank you so much. It was great to hear your contribution. Thank you so much.
Okay,
thank you.
Thank you all.
Thank you.
Okay, thank you, Matteo. And now I would like to invite Kezia Kozak for presenting another interesting paper titled Framework for Evaluating Urban Lighting Alternatives Based on Energy, Light Pollution, and Perceived Safety. So, very interesting topic with the diverse points of attention, let's say. Kaja, are you? Okay, great.
Screen?
Yes, we can see it. So 10 minutes also for you.
All right. Hello, my name is Kasia Kozak. I completed a master's in lighting from the Lighting Research Center at Rensselaer Polytechnic Institute in New York State in 2020, and I'm now working as a lighting designer. This is a presentation using some of the study on street lighting I conducted as part of my master's project in a small city 3 hours outside of New York City, where the municipality was preparing to upgrade the street lighting from high pressure sodium to LED. Having lived in Troy, the city being studied here for several years, I wondered if there was a way I could help them find the best overall lighting solution and not just cut down on their energy consumption. This is how I ended up using some existing research from the Lighting Research Center to evaluate the fixture options on a variety of criteria to help determine the best product for key scenes throughout the city. It may seem obvious, but there are links between street lighting and reduced nighttime vehicle crashes. Light can also make streets and sidewalks safer for pedestrians by helping them see and be seen. There's data to support both these claims. Lighting can also enliven pedestrian streets when used right and increase feelings of personal safety and security. But it can also cause discomfort with glare and light trespass, as well as negatively affect the environment with sky glow and high energy costs. Some lighting can even contribute to potential negative health effects such as disrupting circadian rhythm. So how can urban lighting strive to minimize the negative and increase the benefits of its effect? Well, in an urban downtown, pedestrian safety is especially important. Numerous studies have investigated the minimum light levels needed to support safe pedestrian movement, such as tripping hazards or changes in elevation. Visual performance analysis and visibility experiments represented by the graph on the top right agree that a minimum illuminance of 2 lux will allow older pedestrians to see small hazards a few meters ahead. Yet, as we know, there's a big difference between physically being able to see and emotionally feeling safe. Investigations conducted in New York City, clearly a very large city, and Albany, a smaller city, showed that average levels of at least 10 lux were necessary for people in both locations to start to agree that the lighting made them feel safe. This is shown in the graph on the bottom right. But it's not just about light levels that matter. Spectrums such as correlated color temperature or CCT can influence scene brightness and in turn influence safety perceptions. Uniformity plays possibly an even larger role of creating a perception of safety in outdoor lighting. More uniform illumination makes people feel safer at night. These claims were put to the test in 2 studies conducted by the Lighting Research Center. In one study, a scale model parking lot was fitted with LEDs that could provide a range of light levels, spectra, and uniformity conditions shown at the top right. People viewed these scenes and rated how safe they thought they would feel walking alone across this lot under several different conditions. This study was able to validate the outcome of the predictive model shown here by correlating the ratings from participants and the predictive model. Using this model, ratings of -2 represent very unsafe, and safe is set at +2. In a different study, participants visited real-world outdoor locations and judged the lighting in each. These are shown in the bottom right, showing scenes with varying color temperature, evenness, and illuminance. The ratings of the participants were strongly correlated with the predictions from the equation when the average illuminance, CCT, and uniformity were taken into account. This model and the results of the 2 studies demonstrate the importance of uniformity, showing that even low light levels can provide high safety ratings if the lighting is uniform and has minimal hotspots or dark areas. Perceived safety was an important factor in my study of Troy lighting, since the city is considered to be a little rough, but it has a popular small downtown with growing nightlife. For the scope of my study in this small city called Troy, I chose to look at 2 typical urban scenarios: the downtown center, which has ground level dining and retail, and first floor offices or residential areas, and a residential street with 2-story townhomes along the whole block. My task was to characterize the existing conditions via data collection and evaluate some lighting systems to determine the best products for the job. But as I'm sure you know, and I have learned, especially now working as a lighting designer, that there are near endless options for light fixtures. To objectively narrow down the options to the best ones for the scenario, I needed to develop the framework to evaluate the many critical aspects of urban lighting discussed. Using an illuminance meter, measurements were taken in the field at ground level on the sidewalks and roadways for the two streets. Photometric models were then made to mimic the existing conditions on horizontal and vertical surfaces. The downtown area had some very high light levels, up to 225 lux, which is far brighter than necessary. And I observed very glary conditions as well as significant light trespass onto the upper level tenant spaces. The results of the measurements on the residential neighborhood were quite the opposite, with low readings of 0.1 lux on the sidewalks, which not only did not feel safe, but it was honestly hard to see. A resident even came up to me to ask what I was doing, thinking I worked for the city, and complained about the dim lighting conditions on her street. There was, however, ample light being thrown into the windows of the houses near the light poles. I was sure that LED fixtures could be used to find a better solution. So based off the observations and issues in these two areas and other environmental and safety concerns discussed earlier, I decided on the parameters that the lighting solution should be evaluated against, which included perceived safety rating generated by the equation from the previous slide, depending on illuminance, CCT, and uniformity, maximum illuminance on the building facades, which we wanted to minimize, uplight and glare, which should also be minimized, and energy usage as per the city's initial goal. This slide shows some of the simulations I conducted in the photometric tool. These represent the building facades and a plan view of the street. The city intended to keep the existing pole locations, so that is what is shown in the model here. When you're confronted with so many options, including more that are not shown here, and you're trying to evaluate the options against multiple criteria, it can become a challenge to decide what the best solution really means. I tried to organize the data in this way using visual and numeric components. As you can see, this scenario has a very high safety rating at 1.96 out of 2 as the highest safety rating, but it is probably overlit. It also has a high value for glare and vertical illuminance on the building. So we decided that to get the best solution for each scenario, we would rank each option by individual parameter, and then the parameters would be assigned a weighting value out of 100 that would scale the rank of the lighting scenario based on the importance of that parameter. This system helps to make the data objective, and it is flexible to accommodate different values for different desired outcomes. For example, the needs of the downtown are different from those of the residential street. Using this process, you can just change the weighting factor. And for example, in the residential street, if you really want to minimize light trespass into the windows, because more people are trying to sleep next to those light poles, you can increase the weighting factor for the building illuminance rank. It is also important to note that in this version of the simulation, the top rated solution was not necessarily the top solution for any one category, but across all the categories, it was the winner. So in conclusion, we were able to use this system to find very good solutions for both test areas. The downtown lighting recommendation can be seen on the right. As you can see, we were able to arrive at a solution that provided nice even lighting with minimal spill into the building facades. And although there was a 53% decrease in average illuminance, there was an increase in perceived safety due to more even lighting conditions. And of course, with the switch to LED, we were able to provide significant estimated energy savings. This system could be used to evaluate other criteria than what was shown here. It would be simple to add categories to the framework, such as rankings for color rendering, circadian stimulus, or adaptive control. We like to think that this method will help produce the best outcomes across many parameters and will maximize the benefits to the community. And I would like to say that the city has implemented an upgrade at this time, 2 years later, but with COVID, everything kind of stalled, and they still have terrible high pressure sodium lighting with a lot of light trespass onto the buildings for now. That's it.
Thank you, Keisha. Very interesting research, very interesting. Congratulations. Any question from the audience? No? I don't know if Oh, Matteo, do you have a question, please?
Yeah, thank you. I appreciate so much this presentation. Thank you, Kasia. And I would like to ask, as you can see, I'm a huge fan of vertical illuminance. I wonder if you ever thought about also measuring that parameter and to put it in your consideration.
Measuring it on the facades or like on the
on the vertical luminance or semi-cylindrical, just at above 2 meter high to see how well you can perceive other faces or something like that.
In this situation, I didn't, but that would be a really good thing to include. And it's, yeah.
Thank you. Thank you. I don't know, Ice, if you would.
Yes, I would like to congratulate Kasia for this research. I think it's really interesting. Also, I think because the relationship between safety and urban lighting is so important for this social aspect of lighting that we were talking before. I was curious about how did you calculate this perceived safety? Did you consider age or gender parameters in to predict these safety ratings? Because here in lighting project we are trying to correlate this kind of parameters with the urban lighting, and I was curious about if you have considered this in your research.
So the perceived safety rating formula was developed under a different project at the Lighting Research Center. There's 2 colleagues on the call that were involved in that. I don't know if they want to weigh in if age was considered.
Sure, I can. This is John Bullow. Thank you, Kasia, and thank you. The studies that we did had a range of people of different ages. But we didn't find any systematic difference in terms of younger people versus older people in terms of their ratings of safety. In many of our studies, we have found, even in a laboratory study, where people are in a room and they know that they're inherently safe, but they're still judging a scale model, for example, we do find that there are very small but very consistent differences between males and females. In general, the safety rating on average for females is a little bit lower, about 0.2 of a point on the +2 to -2 scale. So we're looking at an average rating, obviously, in this particular case. The trends are the same. It's just that there's always a little bit of an offset. So that's what we found, but no effect of age.
Okay, thank you very much, John. I mean, I think that was our perception, but it's no. I mean, I was curious if it's really evidence-based or it's just a perception that we have. Any more questions somewhere, or we can just maybe pass to the next one?
Yeah. Just a very short comment, because in our project we are arguing about how to combine light pollution and artificial lighting pollution and perceived safety, for example. So I think that this research is very inspiring also for this, for replying to this question that is of course open. Okay.
Yeah, I believe that there's a download available for the perceived safety rating calculator, possibly on the Lighting Research Center's website. I'm not sure.
Yeah, that's correct. I'll put a link in the chat box for where you can locate that for anyone who might be interested in trying to experiment a little bit with it.
Thank you very much. Okay, so I think that we can move on. Mark.
No, and just thank you for getting up in the middle of the night. Really cool.
Yes,
that's not
Thank
so
you so
bad.
much.
Not so bad.
Thank you.
I was thinking the same during the presentation. Thank you.
Well, thanks for
Okay.
having me.
You're welcome. Okay, so we can move on, and I would like to invite Richard Gedon. I hope that I pronounced correctly your name. The title of the presentation is Challenging Current Urban Lighting Policies, Case for a Shift of Focus to Awareness.
Yeah, hello everyone. Hope that you can hear me, see me, and now you should also see my screen.
Yes.
That's great. Okay,
Great.
Good morning everyone. So yeah, my name is Richard and I'm in the second year of my PhD working with Antal Hans and Yvonne de Kort at the Eindhoven University of Technology. And just to give you a little bit of background about our thinking. So I'm part of the LightCap project, which is a project that's focusing on lighting, the influence of lighting on cognition, attention, and perception. And my topic specifically is the focus of urban lighting and how it influences our attention and safety. And I'm a psychologist by background. So my idea, or the idea that we started with, was basically what is actually wrong with darkness, because if we want to have the people attentive, then I actually think that at least in our personal experience, you are most attentive when you are completely in the dark. That's the moment when you are really aware of your surroundings and when you can hear every twig snapping around you, when you are really, on your toes. So that would be really beneficial for your attention. But on the other hand, it's probably not very good for your, let's say, subjective safety, for your feelings of being safe. But it was, let's say, our food for thought and something to start with. And then we made another step from that, and we actually found out that at least in the research on outdoor lighting and for pedestrians, the focus there's very heavily focused on visual performance and visual performance tasks. So mostly on this obstacle detection and face recognition tasks. So how we can be seen by others. But as we have learned quite recently, I would say, and even from the presentation by Russell Foster yesterday, that there are now multiple pathways how light can influence us. So it's not only through the visual pathway, it's not only how we can see, but light gives us much more. It influences our, let's say, the circadian rhythms, but also our mood and alertness and even arousal. So there's another layer of influence of light. And we think that this is worth researching. And so far, there is not so much research in this domain. So we started by focusing on these three main concepts of alertness, arousal, and anxiety. And alertness is a concept that is quite loosely defined. So we accepted, let's say, a definition by Brown and Bowman, and that's that alertness is actually kind of an enhanced readiness and openness to respond to every stimuli in your surrounding, and that when you are alert, you are able to see any possible changes in the environment. And as I said, it's quite vague concept. It's used in this research quite loosely, or quite, let's say, in different ways. It's mostly used as an opposite to sleepiness, but recent research actually shows that there are differences between alertness and sleepiness. So what we consider as this opposite of the spectrum is more like a wakefulness, and alertness is really kind of this enhanced readiness. And the same applies to vigilance. So vigilance is a concept that is very useful in research for drivers, where you have a very monotonous task of driving on the highway with repetitive lighting. But it's kind of a different thing from alertness. So in vigilance, you have a selective attention to one area of your vision and maybe one kind of stimulus. But in alertness, you are really want to be aware of your whole surroundings. The same goes for arousal. It's a concept that's very much linked to all the others. And it is much better research. So we approached it through the way of this activation deactivation adjective checklist from Thayer, who divides arousal in two main dimensions. So the energetic and the tense arousal. And the energetic arousal is, as the name suggests, more connected to like our activation and energy, and can be also with the sleep-wake cycle. The tense arousal is more connected to feelings of safety and mostly to anxiety, which brings me to the third concept in our framework, which is anxiety. And we are again looking at it rather through a psychological, more evolutionary perspective. So anxiety is actually aimed or intended as a beneficial function of an organism. So it was useful during those times when we were really threatened and by our surroundings. So it gives us kind of like a safety mechanism in these uncertain situations when we can increase like our alertness to the surroundings and be more attentive when we feel threatened. And this is important because also in the research on lighting and for pedestrians, it's mostly focused on these ideas of like fears, but fear in definition is for something specific. So you can be fearful of like a specific stimulus, but anxiety is about uncertainty. And in truth, in the real world, it's more that we are, if we are feeling unsafe in the environment, we are not fearing like a specific stimulus, but we are uncertain of what might be there in the dark, right? So it's more in our approach, the safety, we consider it as an absence of feelings of anxiety. And this is the triad framework that we decided to use. So we have these three main concepts that most probably influence each other. As was mentioned, alertness, any increase in alertness is kind of followed by increase in arousal. And if we increase the arousal in this kind of negative tense sense, it's also probably increase in anxiety. But as I said, anxiety might be beneficial, so it might increase our alertness. So they are kind of all three connected concepts. And we thought as a first step, it would be nice to follow a very old study by Harold Bird from 1916, who actually found that in his research, the participants did better, performed better in 3 tasks under non-uniform conditions. So he had this division of 2 types of lighting, and in the non-uniform conditions, the luminaires were at different distances, more apart, and at various distances. So they were like, let's say, larger, those dark and light paths under the luminaires. And in these non-uniform conditions, when the participants had to walk through the dark areas, they actually performed better and they were attentive more, which is, well, very interesting finding. And we just like decided that it would be nice to kind of replicate this study 100 years later with a modern approach and modern tools. And we also wanted to look at it through our framework. So what might be the cause behind this? Maybe it's the increase in arousal, but we don't know what is the nature of the arousal. So is it the increase in the energetic arousal through the light areas, or is it the increase in the tense arousal? So the participants were, let's say, more stressed or more fearful, and that's why they were more attentive of their surroundings. So we did the replication. We chose 4 streets with different lighting conditions and let the participants walk there alone, listening for 2 sounds and responding with buttons to those different sounds. And the main finding that we actually, to our surprise, found was that the participants really did better on the streets which had the worst uniformity. So on, let's say, the most contrasting, the street with the darkest patterns, and yeah, the participants were doing the best. But it was a field study. We had a lot of, let's say, intervening variables, a lot of confounding factors. So as a next step, we now are conducting a virtual reality study. So the setup is basically the same, but we use, as our environmental stimulation, we use virtual reality. And we have already planned another following steps where we want to manipulate one of the 2 concepts, mostly the arousal. So, like, main conclusion from all of this is, as I mentioned in the beginning, these concepts like alertness, arousal, anxiety are not really considered so far in the research for outdoor lighting for pedestrians. And it seems that there is a warranty for further research because of our findings so far. So there might be multiple pathways, as I mentioned, that are influencing our attention and safety. And if you look at it through, I would say, a rather wider perspective, it actually could bring us much more if we are not focusing only on, like, let's say, the engineering perspective, only on the lighting properties. But if you look at it from this lighting design perspective, then it can bring a lot of ideas from architecture and urban planning, and it can actually much more enhance the whole design process. And in the end, if the policies are today based solely on this visual properties, then they are probably neglecting some important concepts. And yeah, thank you. This is my last slide. Just thanks for all my students that helped me with the research.
Thank you very much, Richard. Your presentation was again very interesting and pose additional questions, at least to me.
Yes, I can imagine. Yes.
Any question or comment from the audience? You are very shy.
Anyway, just on my part, it's also a comment more than a question, because I guess that we'd have to go much more in detail and also read some longer presentations, etc. But perhaps, it's very interesting to see your presentation against the one that was just made prior, and how they can all or how they respond to each other or complement some issues. I think it's very, very important to go much further in the definition of safety, in the definition of the feeling of safety and security. And that is really not something that is appreciated by everybody in the same way. So the research goes in various directions. So it's really very interesting. Also, I think that the concept of uniformity is really challenged by what you just said. So on the one hand, we had a presentation that really said uniformity is the main criteria, and you're saying perhaps not. So that's very interesting. I think that's research, so there are perhaps not a lot of questions, but it's at least very interesting and challenging for the urban lighting world. We have a question from Peter Thorns, so perhaps you want to ask a question, or you want to react directly, or
I'm sort of interested in how we apply this, because one of the reasons that we've always gone down the route that we light surfaces and we light objects is that they don't change. A wall is always a wall. If you light for people and alertness and anxiety, not only are all people different, actually each person can be different depending on their previous history. If you've had a good day, you're likely to be more relaxed. If you've had a bad day, you won't be. So how do you feel we can actually translate this sort of lighting for people into something that we can use generally as a design process?
Yeah, that's a big question, big problem. I think like what comes closest to this idea is probably the concept of dynamic lighting, but it also brings like a different, let's say, different set of problems. But one of the things that I kind of like forgot to mention, or that I, since it was a field study and there were like, many different factors, so we were focusing on uniformity or non-uniformity of the lighting. But in the end, we cannot like make these kind of conclusions that this was caused mostly by non-uniformity. It could be caused by many different factors in the environment. And at the same time, so as I said, like this idea of darkness or less light that could be beneficial for our attention and attentiveness is nice. But as I said, we also like we're checking for perceived safety. And the perceived safety was lower also on the darker streets. So it might not be beneficial in this, like, let's say, individual sense. So yeah, everyone is different. And it could bring another set of problems, because also like with dynamic lighting, it's this thing, like people do like the light in their like near vicinity, in their immediate surroundings. And if it would like, how would you set it up? And if they don't see what's ahead, they could feel scared, even though they would be attentive. So as I said, I'm like in my second year of my PhD. It's rather like an exploratory study, and I think we actually just wanted to try out the tools and see how it works. And we were really surprised that we managed to replicate the results in the end, and that there might be something more to this idea of utilizing the darkness for, let's say, our benefit, but how to really apply, that's a big question. I just think that it brings possibilities, right? It brings possibilities to look at light also from a different perspective than just from, let's say, engineering. So just looking at the spectrum or brightness or luminance or, you know, different properties of light. But it can also, we can also think about light in this design perspective. So where do we aim it, and what do we highlight in the environment, and then so it can also bring some, I say, aesthetic possibilities or so, but solutions, yeah, I don't have any at the moment.
Yeah, I think it's really hard. You're at this start of the research also, and it's really hard to imagine how to translate that into design and policy and practice. That's great, but I think it's a very good avenue of reflection. How to, you know, speak to the deeper layers of also human nature, and how to use that, I think, in the psychology and realm, and how that will have a big impact on our consciousness of the environment. So yeah, keep it up. Thank you. Thank you so much.
Thank you.
Thank you. Thank you, Richard. Okay. Next presentation will be given by Tim Ant, I suppose. Yes, Tim, welcome.
Hey, thank you. Can you hear me okay?
Yes, perfectly.
Brilliant.
The title of your presentation is Leveraging Digital for Communication with Stakeholders and Communities to Improve Nighttime Design for Safety and Comfort. Case studies from ARUP. The floor is yours.
That's right. Awesome. So can everyone hear and see my screen?
Yes.
Fantastic. So good evening from Melbourne in Australia. Thank you for this on a Friday night. But it's awesome pleasure to be able to talk about this and share this journey that we've been on. And I actually hope to be able to answer some of those questions that were just raised in the previous presentation. I'm hoping that also you listened to my colleague Hoa Yang speak yesterday. She previewed some of the research that we did, which is the basis of this work. And you might recall some of the data sets that she showed. Just to recap, we did a evidence-based crowdsourced research project where we listened to the voices of women and girls and how they feel and perceive safety in cities. In this case, it was Melbourne. And what we were really interested in is so many of those spaces talked about light. So she spoke about that yesterday. Brighter not equaling safer at all. Quality is way more important than quantity. Layering and context, so having different light sources, not just one big floodlight, and also the context of not applying the same standards to a pathway that you would to a laneway to a park. And also the contrast ratio, and this is a really interesting example of a space that meets the Australian standards, but feels terrifying. So we're trying to, on a bit of a journey to try and figure out what we can do. We're spreading this message with people like yourselves, where we directly ask people, you know, what you can do. And we say, demand lighting strategy, engage with the lighting design community, and share this message because it really resonates. And we talk about how, and that's what I'm going to touch on shortly. So we talk about master planning. In Australia, it's very rare to have a master plan for a council or a city. It's quite strange. It's like they've just forgotten that darkness doesn't exist, or it's the bastion of lighting design and its fancy, expensive glory. So we're trying to change those minds. Also more co-design, it's really important. And I think, you know, just listening to some of the presentations earlier, and it's no critique or criticism because we're all trying to move in the right direction. But I think asking a lot of people is where we've found, asking normal people, so people in the public, we've found that to be really valuable and gleaned a lot of good information out of that. And what I'm going to talk about today is how we can leverage data and technology and not be afraid to do that. because in urban lighting in Australia, everyone always resorts back to the standards and they go, oh, if we don't meet the standards, then bad things are going to happen. But as we see on the latest crowdsourced data in Melbourne, the Your Ground map, bad things are still happening. So we must improve, and that's where we are today. So what this shows is the latest crowdsourced data just from last year. And basically the lead researcher, our collaborator, Dr. Nicole Calms, she called me up and just said, Tim, it's all about lighting, we must do something. So lighting's mentioned 120 times in her report, which is quite extraordinary. So we hear a lot of stuff of these are the problems, this is what we need to do. But we don't hear much about what we need to do to fix it. So we hear a lot of reports, a lot of incidents, and it's really sad and shocking, and everyone tries to do their best. They might put in more floodlights or more CCTV, but there's so much evidence out there now that doesn't work. So what we're trying to do is use digital technology to take that leap of faith into trying to make things better. And this is why we're trying to pilot things and really learn as we go. So we start by using GIS to map a lot of these sites. And what that allows us to do is actually dig a bit deeper, scratch the surface, because obviously lighting you cannot look at that in a lab on its own. We must look at it in terms of wanting to deploy solutions, or at least test things and pilot and continuously improve, because we do know now that what we're doing broadly isn't good enough, or time's moved on. So bringing this into a GIS realm, what we can do here is we're showing all the sites that we measured things, and what it does is triangulate them closely to the nearest public transport. That's a big thing for us, and I'll touch on that later. All the red dots are all the original data sets that we used to get this information. And then, the blue numbers are where we went and did these measurements. And we just measured general lighting things to try and really understand the qualitative and the quantitative reasons why these women and girls specifically would have left these remarks on this survey. What it's led us to do is come up with a thing we call a lighting vulnerability assessment. So it's an evidence-based tool that we're trying to use now to help our clients. We've developed this with our risk and security team in-house at Arup, and it's been really interesting. So what we do is we take the existing site conditions, we do a contextual element assessment where we look, is it an open space? Is it a park? Are there trees? Then we do a physical site characteristic assessment. So we really use SEPTED processes that security team have taught us, but also we're looking at, basic stuff like reflectance. So is the floor concrete or is it asphalt, tarmac? They're really important. And I use the analogy normally to people, you don't probably paint your lounge room black because it just doesn't work. And so it's really trying to get them to understand why surface reflectance can be a massive improvement in the perception of safety. And then we do a technical lighting assessment on top of that. We do site analysis, like I mentioned. We use brightness and luminance and HDR imagery to try and understand contrast ratios, because what we've found is actually contrast ratios are the biggest influencer of perceived safety. So we talked about uniformity earlier. We talked about how we, not having uniformity. It's actually more important about the contrast. So you can have uniformity or non-uniformity across a asphalt surface, but you may find that it's perceived as unsafe because of things that aren't just lighting. We also work with others, wayfinding experts, and understand sites. So this site here is a big square in Melbourne. The grey are the buildings, and we just look at the entry points and how people use the space, because we always got to come back to people using it. And then we do an LVA summary, which gives the analysis and gives them areas where they're most vulnerable. And what we can do is break down these over a master plan and really help clients do stuff, because what we're finding is sometimes doing stuff seems too hard or too expensive. So if they can break it down, it's much, much better. So these sites are established based on the data set, the correlations previously, and we apply that going forward. And what we ideally want to do is actually get more data and go forward in a different way for each context, because we can't just use the Melbourne data to roll out across the world. We're also doing site-based community consultation, so not always digital or digital with your fingers maybe, This is super rewarding and really amazing. We did one earlier this week, actually, in the summer here, which is a pain because it starts at 8:30 at night. But to understand how we make better spaces for people, for everybody at nighttime, we have to teach them about lighting so that they can tell us how they feel. So it's a really important message to take away from this. So we use torches from a hardware store, which we tried on this one here with very fancy lights, but people were reluctant to touch them because they're big, heavy, and expensive looking. So we get real positive and good outcomes just with a load of different torches. But it's really about listening, and then we use that information to go into our design process. Another way we do it at the moment is using online community consultation. So this is using the scans of the sites that we have done over our time, and our 360-degree nighttime scans. And so we're building a website where I can host a webinar and get the public to log in, and they can zoom around and spin around all these different sites, and they can use the pointer to click on a specific site, and they can tell us how they feel and all those kind of things. Here's another part of it as well, just showing now. So the green equals good, red equals bad, and it's taking it again out of the lab. It's giving it to the mums and dads of the world, just normal people, and really listening to what they say. And this way we can have a broader reach. And this was borne on by lockdown COVID times. The client ends up getting information like this, and like I said before, they can make those judgments and assessments going forward, and it just allows them to rank using evidence to do that. I'm conscious of time. I've blabbed on a bit too much. The last thing we're doing is called a brightness journey. We're finding that a lot of projects we work on and a lot of issues are around site boundaries. People, doing a new train station where the scope stops, then people just forget about that transition, and it goes back to contrast and how we perceive space. And I think the last thing, the purpose we're doing this is really trying to understand user experience and how we can influence that for different demographics. We don't profess to know it all, but we've got a method, we think, that can help us go forward. And then it touches on broader environmental things like 15-minute neighborhoods, walking and riding, and shared value as well, which is a thing we're getting into at the moment, where corporations can do social good. Thank you so much for listening.
Thank you, Tim. Thank you very much. Very useful tool, I think, for the municipalities. It could be interesting to be implemented also elsewhere. I have a question, but I don't know if it is convenient. How much does it cost?
Well, we can do you a good deal.
No, you don't have to.
No, we're still trying to figure that out. The good thing about working at Arup is that we've got an internal investment and research department, and so some of this has been funded by them, and so we use that to solve our problems or our clients' problems. So there's a lot of faith gone into this, and we're trying to push it because we believe in it, and we know that it can be scalable. That's why we've digitized it, and we, as we do more and more of them, we'll be able to start to price them properly. Okay. So we haven't done that to the best of our abilities at the moment. So I'm hoping none of my colleagues are on the call at this very time.
Okay, no, thank you for also for this answer.
No, it's important because, and where we work, lighting design. I used to work under Florence Lamb in the UK for Arup, and I come back to Australia, and lighting design is very still boutique over here. And that's why I said in the earlier slides, engage lighting designers. Don't just engage an electrical engineer to, chuck a few lights there or meet the lux levels. We are beyond that. So yeah, it's a good question.
Okay.
Yeah. Thank you very much, Tim. I mean, it's really interesting, and you'll have some other questions, I guess. I think for cities at the moment around the world, one of the big questions is safety and security policies, and how to involve local stakeholders in the design of these policies is really important. And ultimately, not only the design, but then the co-production of these policies. I mean, that's very important. That's one thing. The second thing is the inclusiveness. So how do you include various parts of the population, women, young people, senior citizens, and how can they be very much involved and not only, this passive targets of public policies and play an active role. And I mean, that's really important. And one of the big questions is, how can we have the digital world in there? And does the digital tools really help us to answer these questions? And I think you've shown that it's probably the case. So I'd like to really hear more. And it's really interesting to build in this digital and analog together. And so that was perhaps just a comment. I'd have a lot of questions on, the data side of it and how you process the data and how you maintain, analyze data, because that is actually key. Once you start to go into detail with those digital questions, you have to go in detail into how you analyze data and how is the ethics around this, how the transparency and how you engage as Arab towards your clients, I guess, about this data, and how do you share this data after you maintain it in the future, et cetera, because that's really important for cities to see the level agreements of how you deal with that. But I guess perhaps a more easy question, I don't know, how do you make sure that less tech savvy people, older adults, get a say? Because Enlighten Me is really focusing on older adults. So perhaps enlighten me on that too. Thank you.
Yeah, lighting puns are always welcome. So thank you for that. And you make heaps of good points, and I'm more than happy to follow that up via email or phone calls going forward.
Great.
For us, the torch workshop is the most inclusive thing we can do. Because you're really, it's a torch from a hardware store for like, 20 euros. And people hold them, like we're on Tuesday night, someone dropped them, and that's okay. But what you can do is then you can go, hey, point the light down, point the light up this bush, light up this bit of grass. Tell me how you feel. What makes you feel safe? So no one goes out there and walks around with the lux meter, apart from their eyes. But like, we're so focused on numbers and all sorts of stuff, which are meant to save the world for everybody. So we can go all the way down, or we've been going all the way down to basic level. We've even had children come on these sidewalks, and we walk around their own community and they tell us how they feel. I mean, I can't sit in an office and tell them what's what. We must listen. And do you know what? It's really enjoyable. And so that's how we include everybody. But I guess for clients and municipalities, what we prefer to do is partner. So we don't do the data collection ourselves. We partner with XYX Lab.
Right.
And so we try and keep that separate. Again, it's more fun. They're experts. We're experts in light. And then we look at those correlations. We go to those sites. It allows a client, like a council, to go, okay, there's a fair bit of issues here that we need to solve. Let's do a little pilot study here. And then let's learn and listen. And then we can do another pilot, and then it should grow from there. So that's the broad process.
Cool. We have two questions. One's from Kesha that held her hand up first. So perhaps Kesha. And then Peter Thorns.
Sure.
Hi, so more of a comment. I have some colleagues who have this company Scan2Plan where they collect LiDAR measurements, and they're thinking of expanding to just scanning entire cities and then trying to sell that data to the city for various reasons. We were discussing, like, is there value to like scanning a city at night? Well, of course, I was offering that it would be useful, but I think this was really interesting to me to see like the concrete results that can come out of having that data and like what you can use it for to benefit the community. So I just wanted to say that was really interesting.
Yeah, I mean, it's new. I'm a lighting designer. I'm an industrial designer by training. So I'm learning so fast with, fantastic. It's the best degree. No offense to anyone else. But I'm learning about data and all those kind of things as well. I guess one insight that was funny for us is that when we did the online community consultation, and you can spin around like a Google Street View, we take all our own images. We also did a pseudo color. We did the colorful images. And every time we went around to clients and said, give us feedback on this, they were like, what is that? We don't understand any of that. And it was a case of all us lighting nerds getting a little bit caught up in all the technical stuff and really thinking something else was important when it actually wasn't. So the scanning at nighttime is good because you can continually go back to it. You don't always have to go out again, and you can bring more people along for the journey. So yeah, just, I guess if you're going to scan stuff, I'd recommend knowing exactly what you need to do and why. But it's cool that you're thinking about that.
Great, Peter.
Yeah, I enjoyed the bit with the torches because I've done something similar, and it actually gives you answers that are frequently totally against what you expect or what you think you should do. And that comes back to the idea that if we light to standards, we get sharp edges. So either you've got light there and it's got to meet the standard, or you don't have light there and it's dark. But you tend to find that cities, corporations, urban areas are almost keeping an eye on legal. So if anything happens, am I covered? I met the standard, I'm safe. So have you any thoughts on how we get around this problem and how we can start lighting spaces that maybe don't meet the standards, but are actually better places to be?
Yeah, so that's almost like I set you up with this question. So thank you. You've got to be brave, and I've definitely upset some people in my time because you come up against 30-year veterans who have done lighting for train stations, for example, and they don't see a problem. So I guess what we try and do is how I did the presentation yesterday about the research. It's so compelling, it hits you in the heart. And so we share that with clients and we say, well, actually, we acknowledge the standards, but we'll take you to some places that the standards are met, but that it's still terrifying. So what we do to mitigate that so far, and we're actually working with the State Department of Justice here as well on some projects and pilots. We say if the community has helped design this, then you must have the confidence that it's okay. If you decided just to implement it based on some science or a hunch, then it's a bit different. But we say if you've founded upon that, you've listened, then this is why you should have the confidence to go forward, irrespective of the standards or not, because what you'll probably know already is that often the best results don't meet the standards. I hope that's kind of covered a little bit.
Thank you so much, Tim. I mean, that's been really interesting. There's lots to bring out of that too. So thank you very much. And also for being with us at 8 p.m. on a Friday evening. You know, it's great. Now you can enjoy your weekend, I hope, in a few hours. We have a lot of more presentations coming up. Thank you again, Tim. Thanks.
My pleasure. Thank you all.
Thanks.
Thank you also from my side, Tim. Yeah, we have 3 papers more to be discussed. So I would like to invite the next one, Urza Uriarte. I really hope that my pronunciation is correct.
Yes.
Hello.
Correct.
Hello, Urza.
Hello.
Your presentation is about simulation of daylight by radiance in dense urban areas. So a pretty diverse topic in the sense that in your presentation we will focus more on lighting that could not be only artificial, but anyway, very challenging topic, especially for the historical areas of our cities. So the floor is yours. Thank you.
Okay, thank you. Good morning, everybody. My name is Urza Uriarte. I'm a postdoc of the University of Basque Country. I have done a abroad study at the south of France and then in Bayonne. And there I am researching the simulation of the light by radiance in dense urban areas. So my research, I'm going to explain my research, my currently research is in the context of dense urban areas. We can see that in many cities, we have very dense urban areas. Especially in downtowns or old towns. Here we can see the old town that I am working is the old town of Donostia San Sebastian.
Sorry, Urza, if I interrupt you, but we are seeing the presentation not in presentation mode. I don't know if...
Okay, I'm going to wait a little. A ver.
Probably you have to try to share your screen, not the presentation, but I'm not so expert.
Yeah.
For the share screening, the best thing is to open the application. Then when you click on share screen, you can choose the application directly.
Okay.
Try in this way.
Okay, so I'm going to share this one. Yeah, you can
Okay,
see.
perfect. After you can choose the show, yes, the slideshow mode.
Okay.
Click on it.
I have done it, but I don't know if it doesn't work.
Click again, because I think that is not taken by the...
Click again.
Or you can try with the F5. Usually F5 starts the show by the computer.
No.
No. Okay, you can go in the PowerPoint menu in Vista.
I'm going to stop. Okay. Here.
No, on PowerPoint, you can check on menu on the upper side of the menu. You can click on Vista, the menu Vista, and from there you can give the entire screen sharing, the entire screen mode from PowerPoint.
Okay. I don't know why I have the two presentation. I'm going to stop with that. Perhaps I'm going to open again.
Yeah.
Yeah.
But after you open PowerPoint, the PowerPoint, click on share screen by Zoom.
Okay. So first I'm going to share the PowerPoint. Okay.
Yeah.
And then.
Okay. Now you can try with the slideshow. Down in the bottom part of the PowerPoint.
The bottom part.
Yeah, this one. Click here.
Doesn't
start. It's really strange.
It's really strange.
I can try to share the presentation because I have it.
Yeah. Okay.
We can do it this way. Okay, this is...
I don't know why.
Okay, but now you have to stop your share screening, please.
Yeah.
Just to give to Elisa the... Yes.
I will do it in a moment just to understand how to do.
Yes.
Okay, and Elisa, if you click in Control L.
I do it this way.
Yes.
Is
okay, perfect.
Okay, just to
okay, to move on. I say you to change the like that.
Okay. No, you can also ask for the remote control directly to Elisa. If you go in the upper part on the menu of Zoom, you can say the black button with the option.
Yeah.
If you click there, you can ask the remote control to Elisa.
Yeah.
In this case, you can use directly, and you can go on with the presentation.
Okay. Excuse me. Thank you very much.
Yeah, you're welcome.
You're welcome.
No problem. You're welcome.
Okay. So in many cities we have dense urban areas such as Old Town or Downtown. Here I am working on Old Town of Donostia San Sebastian. We can see here the dense of the urban area comparing with others or surrounding urban areas. So in this context of dense urban areas, the daylight is a little bit there is no so much daylight, and I'm going to show in the presentation the research. Okay. Next one. It doesn't work. Okay. Why doesn't work now? Okay. Okay. Now I have to turn back. Yeah. Now, yeah. I think it works. Oh, it's a little bit complicated. Okay. So the topic is the light wells of these urban areas. We can see that in these light wells there are some issues. We observe that they are dark and wet and a little bit unhealthy. So this is the topic to a little bit to have better conditions. So in the current state, some light wells, we can see that they need for enhancement. So this enhancement we can start with very simple intervention as have its all dimensions of those light wells. We can see that there are a lot of obstructions. So this in the urban policies, we can ask there to control these light wells situations. Another very simple enhancement could be painting with everything in white, because white we can reflect a lot of light and conduct inside of the interior rooms, especially in the rooms or the first floors. The objective of my research is simulations, so simulation rooms with low light, and this requires precision, okay? Because with a very low light, we can see that is very common that simulations that are not very accurate, and we don't have very accurate results to know what's happening in these first interior floors. Here we can see two interior room, and then the daylight amount is a little bit low. In the first, we can see that it's a little bit white and gloomy. That is because the create of a graphic with the comfort with very low light level, the white color sometimes is a little bit gloomy, and the luminosity as well. And in contrast, in the second picture, if we have a little bit more warm surroundings or atmosphere, the light perception is higher and the comfort as well is higher. These the color aspects I'm trying to a little bit show in the future steps. So the method of my research is that objective to more accurate simulation. There I use the method of the simulation with ray tracing, with radiance. In the last workshops, it was in Bilbao as well of radiance. I'm in contact with the community of radiance. So the first step is to get the more discretization of the sky, and that is to get more accurate sky modeling to get more accurate results. So, on the other hand, we have reflection coefficients. This is important as well because the reflection coefficient is not accurate. We don't know how much light we can conduct inside. So, this reflection coefficient is about materials' optical properties. And for that, we are trying to get photographies and the reflectometry meditions with to get BSDF functions. First, we do the measuring campaign. This first measuring campaign was in the old town of the Donostia San Sebastian. We can see here the light well that we selected, and this light well, it was between the street Esterlines, Narrica, and Beltran, and we can enter this interior for Esterlines Street 3 from the first floor. This measuring band, it was in May, in last May, and the measurements frequency, it was every hour, is the point time measurements for only one day from 4 p.m. to 8 p.m. And the measurement site were roof and the flesh floor interior or room with window to light well. We put 2 laxometries, one at the room and another one at the first floor interior, with 25 centimeters from the window and 40 centimeters from the wall. We can place as well a camera in the sky and interior photographs taken hourly as well, and one reflectometer to get optical properties with interior walls to get the BSDF for these interior walls. In that day, the sky type, it was intermediate. That is very important to know. Starting with half overcast and turning to clear sky. Okay, the measurements campaign, we can see here that we have in the roof sky, we put a photography and take 2 photographies and as well measurements of light levels. This is the window to the light well. We can see here the type of the window, yeah, that we are testing. Okay, and the interior surfaces, this is the interior surface that we have the light level as well. We take in the photographies and the BSDF optical properties of materials. In the measurements campaign, we can see that the results of light level, if we take in the roof light level, we can see that the light level is very much at the roof, like 1,000 times more than the interior. So this is very high difference. So the challenge is that this daylight at the roof, this amount of 100,000 of luxes to get inside more. Here the photographs is the sample of one photograph at 3 p.m. and we have Lambert projection to get these photographs is in 360 field of the camp field, okay, degrees, so see 360 degrees. So in different projections, we can see all view of this, the eye, field of eye. Yeah, okay, here we have a Lambert projection and the hemispherical projection. In the Lambert projection for the sky, we can see every sky or 360 degrees sky and the interior as well, and the hemispherical projection. Then we can see that we have some more luminances, high luminances and low luminances results. I work as well in my PhD about glare, so I know that in the comfort, these topics of glare and during these presentations, the glare is very present, and it's very important to control that contrast and control as well the uniformity and to get a balance. In my work, my results are the complexity is very important, because sometimes the contrast is fine for the dynamic perception, but in other times they provoke or they cause glare, and that's not good with the shadow spaces for the safety or this topic. But let we see from another research this kind of topics. Okay, so here there are the optical properties that we take the BSDF, so we can see that okay, so the component of this reflections. Sometimes we have very high reflections, but with a very diffuse component, and another time we have a very low reflection, but with very high specular component. So that is important as well, because with a specular component is easier to conduct the light, but the amount as well is interesting, and direction of the daylight as well. We can see that the walls, for example, because very white is very diffuse component, and in contrast with the bedclothes, we don't know, but if we measure that, we can see that it has very high specular component, and with the floor as well. The reflection is good, but it has very, very high only specular component. So with the sky different discretizations, we know that we have the different sky discretization. Historically, we started with Tregenza with 145 dimensions, and right now in radiance, usually we use the Reinhardt sky discretizations with 580 dimensions until 2,305 dimensions. My director of Straight Abroad, he has 5,000 divisions. Benoit Berkers has the proposal of these more divisions as well, to get more accuracy from the sky, to get more real situations, and then to have more accurate results. Yes, we can see here that the paths of the skies, they are very different with 145 divisions, or if we have 5,000 divisions. These paths is important to know how the simulations can get there. So this, we can see in these paths that there are a lot of difference between the type of the sky or discretization of the sky. Here, the interior world plane, I did some proof to getting more simulation, and to get that their simulations results are fine or not, and to test this simulation. So this is the first step with a very easy world plane, and the hypothesis is that the sky partition is not accurate. The probability of the radiation will be overestimated. And I give here a little proof, one little proof to show that situation. We have 145 dimensions of the sky. Those are the programs of radiance with very high ray tracing rise quantity. And then we can see that in this world plane, we have 60,000 luxes. That is good. And if we compare with the 2,305 division, we can see that these luxes are a little the same, or more or less the same. That is because we use the Peter distribution model, and from every type of the sky, the final of the total flux is the same from every sky. So with this total flux, the contribution is the same. In contrast, if we have a world plane at the room, inside of the room, the contribution of these patches, they are very important to get the direct radiation or to diffuse radiation. So this is another proof, the interior of 581 sensor points to test with different sky partitions. The results show with the 145 dimension, we can see that the maximums are 5 55,184 laxes, and they are disturbing. We have a direct component radiation in red, but we have some results in yellow that there are between with radiation or diffuse radiations. But that is not very normal, because usually when we saw a shadow, we saw a line, a perfect line between direct and diffuse. Okay, so that's this is because in some sensor they are seeing some patches that there are a direct component, but it is not currently accurate. In contrast, with more sky division, we can see with these 2,305 divisions, we get this more accurate limit between direct light or diffuse light. So that is very important to know that the accuracy of everything, like a sky, like a model, to get more accurate results. Here we can see in more detail that we have some sensors, more sensors with 145 divisions with those not accurate results, comparing with 2,305 divisions, that we can see that these sensor probits are low or are less. So in the conclusion, we can say that in the context of low light, it will be useful to get more sky divisions, such as 2,305 divisions or more, to prove whether the results will be more accurate. As we can prove 5,000 divisions, that is not the common division of radiance, but I am trying to get to the radiance simulation these divisions results. So this is a sample demonstration of the first simulation of light wells, and here we have one standard light well with 4 floors, with a sensor grid in the first floor, with the interior at the interior room, with room with 3 meters, and the sensors are between 0.25 meters. The walls width are 0.25 meters, and the window is the simple window. Okay, so here we can see that the results, another enhancement, it could be to get this.
Urza, sorry, yeah? You should end
okay.
your presentation.
Okay. I have that and another one. Okay, so we can see here that if we paint the light well in white, or we can put another material as a specular material, we can see that we can conduct 3 times more light inside on the interior room. Okay. Okay. Okay, and so the next step is it could be another enhancement, that to improving daylight conduction by simulating different finishes of surfaces that I have shown now, or in a skylight complex fenestration systems that they are to conduct with some specular materials and products to conduct more daylight inside. And this is the color aspect as well that I started explaining, that if we can paint in more yellow color, the perception of the light is more about the creative graphic. And thank you, and sorry for these presentations or showing problems of presentations.
No problem, Urza, for for the technical issue, because it's sometimes it happens. No problem.
Thank you.
No problem. Okay. Any question for Urza? And now I can see. I was a bit out of everything, so sorry if I didn't interact.
Okay.
Okay, I think that this message was for before.
Yeah. Here from my side, thank you very much, Urza. I know that daylight is not a specific focus for Enlighten, but I think it's very important for Wellbeing. I know, especially because when I was a student, I was living in this area and I was living in a bedroom close to one of these lighting wells. So I know what is the lack of daylight and how you can suffer if you don't have it. I have a question for you, Urza. I mean, for more the part of urban analytics of our session, I was wondering if there is limitation to make this kind of assessment in bigger areas. I would say all the area of the old town. I imagine that it's very data dense, this assessment, very intense, but I don't know if maybe using satellite data. I mean, how do you see to make it this in broader, these studies in broader areas?
Yeah, the data is very important. We do some point time measurements and daily measurements, or 1 day measurements, but it's important to get more in the year, all year measurements. I have some measurements to put to have a data logger and to get this data to have saved it, and I will put, I think in January I will start it with this year measurements. It's important to get this hourly data to get to the simulations as well, and this. But I know that to measure at the city is not easy to put this kind of tools and from Lightwell, for example, it's a little bit easier because there are spaces that many people is using these spaces, but in other places it's not easy. But we are trying to see another kind of measurements as with satellite as well, or with drones as well, and then to get data it could be easier without disturbing the citizens. So but I hope that in the future this data could be easier to get, because we know to check the simulations. That is the reason that to get more accurate simulations, because with low measurements, with less measurements, because the measurements in the city are a little bit more difficult. So, but we can, if we take some measurements to get to compare and to calibrate the simulations, sometimes it's enough. So I think that it could be good challenge that to know how many simulations and when and what place and the time as well. So I think that is important to know that in the future.
Thank you, Urza. There are 2 more questions for you in the chat. I will read them from Francesca. In which way it is possible to correctly simulate in radiance the specular component of reflection in the different directions? How to simulate the BSDFs?
Okay, in radiance, there is an option to get to the material. This function, the BSD function to put in the one material, is one specific material this is, you know that in radiance we have the material, the texture of material, the color, and and in this kind of texture, you need to put this function. So with these functions, you get all reflections of direct reflections of any ray. So that is interesting because if you have this data, you know very complex materials, how is the performance when they arrive the light, and what kind of reflection and direction they do from this material. So this data is collected in BSDF, and you put in as the geometry and texture of the material. The texture material you have to add as the geometry of a color material as well. I don't know if I explained that, but
thank you.
Actually, this BSDF is with this photometer. You can take with the photometer or also with goniometer. You can get this BSDF. And if you know the material as well, the radiance have to get simulate BSDF with Gen BSDF program, you can get simulate one material to saying what is the reflections performance.
Okay, another question. I really ask you to be very short because we are a bit in delay. Does the good daylight help us to improve our vision? Any studies to support this? I know that this is a very broad
yeah
question.
I'm going to try to explain shortly. Yeah, the daylight improve vision. It's important that sometimes the vision is just a moment. So this is to work as well in this project, the glare from the time of glare, because if this glare is from just the time, sometimes is not very unhelpful. So under daylight, it happens usually that with the glare, because with direct radiation we get usually glare. But if you take the time of this glare, sometimes it has the contrast, it has benefits as well, because we have the dynamic perception, and that's very important for circadian rhythms as well. So I started saying that the complexity, and then I think it's interesting to get more visions complex or performance, to know if the comfort is good with contrast or not, or with daylight or not, or this kind of balance.
Okay, thank you, Urza, and thank you all the other participants for these questions. I kindly invite the next presenter to speak, Raychandar Padmanabhan. Is presenting research about remote sensing approach to estimate particulate matter concentration, a Lisbon, Portugal case study. So we are again in a quite different framework, but what is important is the mapping, the mapping process that yes, we really want to investigate with you. Thank you.
Thank you, Elisa. And good morning to everyone. My name is Raychandar Padmanabhan. I'm from Institute of Geography and Spatial Planning from University of Lisbon, Portugal. And I worked this paper with Paulo Morgado, and I'm working with Paulo Morgado as a research scientist. So the paper is a remote sensing approach to estimate particulate matter concentration. We did a case study for the Lisbon city from Portugal. So why we need to need to study about the aerosols from the atmospheric, because we need to We know the aerosol. It gives the indirect effect on the climate as well as the direct effect on the climate, because of the pollutants from several sources, like from industries or from the vehicles, or from burning or some things. It's directly affects the atmosphere. For example, it gives the acid rain, and also it stimulates the cloud condensation nuclei. So it's the pollutants adds with the nuclei of the cloud condensation, so it forms acid rains. And also it's deposits with the atmosphere, and it reduces the visibility of the atmosphere. And also it gives a heterogeneous reaction. It's like a mixture of or process of liquid, gas, and solids in the atmosphere, and it gives a different impact to the health effects. So when we talk about the particulate matters, there is a types, and also it affects, depends on the types. So for example, that if the particulate matter is at 10 micrometers, so it's like a fine particulates. So we can able inhalable one. It affects the respiratory, and also it's decrease the pulmonary functions. When it sits at 2.5 micrometers of fine particulates, it also gives the skin diseases and skin cancer, as well as the lung cancer. And its ultra fine particle is the 0.1 micrometers. It's increased the risk of heart attacks and increased risk of cancer. We know that these are the health impacts of the air pollution, and also specifically from the particulate matters, but it also affects the brain health. For example, it also induces the neurological and psychiatric disorders such as cognitive decline or depression, schizophrenia, and also the defect hyperactivity disorders. And also this kind of particular matters, it always gives the oxidative stress, and also it makes a protein condensation, and it also induces cerebral vascular barrier disorders. And this type of fine dust, it also damages the neuron cells, and it gives a permanent brain damage. So it's very important to study about the pollutants in the atmosphere where we are living. For example, here we take it as a global burden. So one of the air pollution is one of the global burden. For example, air pollution, which causes the 4th highest ranking risk factor of death globally. And also the studies and research says that 85% of the world population lives in areas where air quality guidelines are exceeded. So 85% of people are living in the polluted place, and we can say it exceeds the WHO air quality guidelines. Mainly in India and China, the pollution's level is more, and it's a millions of nearly 1 million deaths every year causes due to the air pollution. In globally, it's like a 5.5 million deaths according to the research in 2013. So the satellite data can help to quantify the impact of this human health induced by the particulate matters. So when we take it in the pollution in Europe, so one of the more significant air quality concern in Europe is particulate matters. It's a particulate matter, nothing but it's a microscopic suspended particle, primarily available in the urban areas and its fringes. So how we can monitor this kind of air pollution? Normally we can do it with the ground measurements, and we can also measure from the air or space observations, and we need to integrate with the models. So these are the primary concerns we need to know about this evaluating the air pollution monitoring. So how we can measure it from the satellites? Because but the satellites does not measure the air pollution, because we don't have the capability, or the satellite doesn't have the capability to measure the air pollution directly. But we can measure the spectral radiance of the atmosphere elements. For example, we can measure the spectral radiance of the aerosol or water molecules in the atmosphere. So from that, we can able to measure the air pollutions, depends on the spectral radiance. So what is the process in the remote sensing when we need to study about the aerosol measurements? So we need to measure the spectral radiance with any kind of satellites. And we need to know the prior information, because the spectral radiances varies, depends on the features, and also depends on the its characters different. So we need to know the prior information and the radioactive transfer theory. And we need to make a retrieval algorithm to study the geophysical parameters, that is the aerosol optical depth. So we need to identify how depth is the aerosol is available in the particular area or in the city. So from that we can make several applications to study about the pollution. So when we talk about the aerosol optical depth, so when it comes to the aerosol properties, the main important thing is it's optical depth. How depth is the optical? So we can also measure the aerosol optical depth from the ground-based sun photometer, but it's too much costly, and also we need to plant, or we need to fix in several parts of city to calculate or measure the aerosol optical depth. So due to the lack of measurements on the global scale, so we can make it from the both satellite images, because if we want to make it in the global scale, we can't able to do it with the ground survey. So we need to go with the satellites. So normally when we talk about the PM, it's like it's a two categories, like a PM10 and PM2.5. The PM10 is a coarse particulate matters, and the PM2.5 is a fine particulate matters. So the previous researchers gives a strong positive relationship between the satellite-based AOT and also ground measurements. So it always we have the good relation between the ground measurements as well as the satellite images. So so our study also we use both the ground measurements and also the satellite images. So our objective of this paper, it's we need to estimate the PM2.5 and PM10 mass concentration of the surface level, like a human level, using satellite derived aerosol optical depth. So if we need to estimate the PM, so we need to identify the relationship between the aerosol optical depth and ground level, need to analyze firstly. And we also need the boundary layer height. We need to fix the height, whether we need a human level, or maybe the building level, or whatever. We need to fix the levels. And also we need to know the relative humidity, or the two major factors influencing the relationship between the AOD and ground level. So that's the boundary level height and the relative humidity need to be correct. So we are using the MODIS aerosol optical depths to enhance the correlation between the MODIS optical depth and PM2.5 and PM10. So how we can take the aerosol optical depth from satellites? It's like we have as you said, we have the spectral radiance of the different features. For example, for aerosol optical depth, we need to know about the particle size, composition, water updates, and vertical distribution. These information we can get from the satellite's image. Mostly, probably we can get it from the MODIS data. So the spectral radiance like 0.47 micrometers, 0.65, and 2.13. These are the main important spectral reflectance to measure the aerosol optical depth. So we have the availability of MODIS data for 10 into 10 kilometer square resolution, as well as a 3 into 3 kilometer square resolutions. So for example, what is the satellite versus ground observation? Because in the ground observation, we can easily get it for the human level. So for example, we can measure the accurate, we can say accurate or a human level of the PM values. But in the from the satellite image, we can measure the aerosol optical depth, not from the human level, but above the human level. So we need a ground observation to correlate to identify the human level pollution level of the particular place. So it's a more technical. It's say the AOD and PM relation level. So a well mixed boundary layer with no overhead aerosol and aerosol that have similar optical properties, so we can relate it by these equations. And there are different popular methods to estimates. Some of them are two variable method or multivariable method, and artificial intelligence or scalar method. So in the traditional methods, they use the air monitor station to identify the PM values. And also they use the multiple linear regression model. But in the study, we use the artificial neural networks to I estimate the PM from AOD. So for this case study, we use the Lisbon city. It's around 1,376 kilometers square.
Sorry, you have to finish. The
It's
time is finished.
Okay, sorry. Okay. Okay. So for example, this is the results from the PM values from the AOD. It's a red shows the high PM. It's polluted, and the low is green. So thank you. Is that okay?
Sorry, yeah. No, if you want to summarize a bit more the results, you can, but
but the time is So we use the ground-based measurement and also the satellite data, temporal PM concentration, to identify the estimation the PM values of the Lisbon city. We use the MODIS Terra data and develop the artificial neural network models to map the ground level PM concentration. And also we also validated the ground-based PM concentration to test the efficacy of the model of from the satellite images. And by estimating this concentration map, we found with no data gaps or discontinuity can be studied in the futures. So this results delivers the potential use of MODIS data sets for PM estimation at regional or global level. Thank you.
Thank you.
Thank you.
No, sorry for the pressure, but we have to run a bit.
Yes, no problem.
Okay, any question for Rajchandra? I know that the topic is quite
far from the
far, but the modalities could be similar.
I think it's not so far, no? It's connected with the urban analytics, and I think these kind of models are going to be more and more in the future used. I think it's good also that we have a view of the state of the art now. And clearly pollution is one of the big issues for health. So I don't know if there is any question. I'm not expert in this issue, not at all. Is there any kind of concern regarding using artificial intelligence, these kind of algorithms to make decision? I don't know, it's not only for this in general, no? I mean, I know population is now algorithm is taking a lot of decision, and we don't know what is behind these algorithms. So how do you see how it should be this transparency? So if we are making decision based in artificial intelligence, how we should transmit to the citizen what is behind that? That is a concern that I have at least myself.
Yes, we use the artificial intelligence because normally they use a multiple scale linear regression models. So here we want to use the other parameters like relative humidity or temperature or wind speed maybe in the future. So if the artificial intelligence, we can integrate the things in the future as well as, and also we can train the model. For example, we train the model from the ground measurements, from the ground data. So we can see the accuracy is much higher than other models. So that's why we prefer the artificial neural intelligence. Thank you.
Thank you. Other comments or questions? Matteo, please.
Hi, Rajchandra.
Hi.
Thank you for the presentation. I have a technical question. I don't know if it's the right place to do But I see that you state that you use the Rayleigh scattering, and I wonder if it's just a simplification, or you can also use the more broad Mie scattering, because I think that in this case the particle diameters is almost as big as the wavelength.
Yes, yes, you are right. The MI scattering is it's good for the highest diameters. I'm right. So in here I show the Rayleigh scatter. It's just for the basics. How we can use the remote sensing data. So as you said, it's a MI scatter is the better for the aerosol optical depth. Yes.
Okay, thank you so much.
Thank you.
It could be interesting for the scattering also, the light, for light pollution, for example.
Yes.
It can begin with the aerosol particle, but you can translate it to define the aerosol in the atmosphere, to evaluate how much of the scattering could made for the light to contribute to light pollution, because
yes, we can use the VIIR satellite images for study the daylight pollutions. Yeah, as you said, we can use the same scattering in the VIRS satellite data.
Yes, because there is almost a debate on how much the light is scattered through the atmosphere. Because, for example, I saw a recent model of Mark Ove, and he used it halfway from Mie and Rayleigh scattering. So it could be interesting to see how much light could be scattered, depending on the atmosphere and the particulate on the atmosphere.
Yeah, you're right. Thank you.
Thank you.
Thank you both. If there are no other questions, we can move to the next and last contribution. Thank you again, Alexander. So I would like to invite Elisabeth Silva. Hi, good morning. She will present us a contribution titled Emotional Maps Portraying People's Feelings in Urban Areas Using Social Media Data. That is very interesting way of gathering information.
Yes. Can you hear me well?
Very far.
Very far? Just a second. Let me see if I increase the sound. And now, can you hear me better?
Better, yes.
Okay, perfect. So, and the PowerPoint, can you see it too?
Yes, try to change the, to move to the showing mode.
Yes, I think I did that.
The bottom, yes.
I think I did. Let us see if it's better now.
Okay, great, perfect.
Yes, I apologize that I didn't put the background from the
No problem. No problem.
We are very thankful that we are allowed to talk. So thank you very much for that. Okay.
You're welcome.
So we are showing work in progress. Okay. So these are some of the first results. As enlightened me, the project Emotional Cities is an Horizon 2020 project. And basically this is a part of a couple of different work packages. Our work package is, I think some of my colleagues are also presenting other parts of the work package, so I will just do a very quick overview. So, I'm Elisabeth Silva. We have three other researchers, Dr. Aysen New, Mrs. Anna Serafin, and Shimang. The work package is organized in 5 tasks. So we need to develop a methodology for urban health analysis. In this, there are several subjects. So from urban metrics and methods to socioeconomic data that comes from different areas, from the census to local data. And in a way, social media is included in this local data, okay? We are also doing zoom-in analysis in 4 case studies: London, Lisbon, Copenhagen, and Lansing. Okay, and one of the goals is to map the emotions triggered by the well-being, the built environment. Okay, so we want to see health and well-being from an emotional perspective. So we are doing this in terms of built environment and so forth. Obviously, we can include two light conditions in this group. So are you happy because the light here is nice? Are you okay? We are doing this in a 3-layer strategy. So we want to have a bottom-up process using social media to understand how people think, but we also want to understand a policy to science perspective. So we want to try to understand if, to a certain extent, policy being issued is sensitive to these issues or not. So are they including our concerns regarding health and well-being? We are also doing this in a 3rd-layer strategy that is science to policy. So we want to know to which extent research is being included or can be included in policy, okay? In this approach, we are linking social media data with text mining traditional data. We are focusing in this presentation just in the sentiment analysis and hotspots. So I will show you some examples on how we harvested data from social media geotagged data in order to identify these emotional reactions. And then we link this to a standard worldwide lexicon that is relatively known, very well known for those working with that detects sentiment, if it's negative or positive, emotion, you know, so links all these words to anger, anticipation, you know. So, and how it is, what did we do, or how did we proceed? We all, some of us post information in Twitter. We run an API, so a search algorithm in Twitter to collect data. Okay, in this collection, what we did is that we defined just that we wanted geotagged tweets, so words that have a geographical location. So we collected everything, so we didn't use any keywords to start narrow down data. We considered all tweets in a day for all the case studies, okay? And then we started to clean the data, okay? We always did this because the 4 case studies have used English, but also Portuguese, for instance. So we always consider the native language plus one more language, English, okay? So when you harvest data, you will see that there are sometimes 30, 40 different languages because people tend to post in their native language, okay? So once we did that, we pre-processed the data, or this was the overall goal, inferring age and gender, but also the sentiment using the lexicon, okay? The lexicon, okay? This is a National Research Council Canada lexicon, looked at emotions, okay? And allows us to see how people are feeling. Once we did this, we start to map hotspots. The first problem we have, and that many people in these areas are having at the moment, is that there is a shift. So in the past, when we collected data, we used to do through streaming that only included 1% of data. And we still do that, and it was running. And just to give you an idea, we were still looking at 1.3 million. So this will be huge data sets. But at the moment, we are moving into academic APIs that allows us to collect all data. So many of us, when we are doing this emotional analysis, the first question is, do we have the capacity to collect? Because if we can have 100% of data, it's better than having just 1%. So for that, what we did was we developed a strategy where we felt it was very important to do pilots to understand if a regular streaming of 1% or an academic API will collect the same data with the same quality, okay? So we did this in August, and I'm going to present some results. We did this, And the goal was to understand if in 2 time periods there will be a difference. And then we plan to collect the data until 2022, August 2022. In these studies, you have some results here for August 2021. You can see for London what was happening. The data points, you see there is a concentration where you have more points of interest like parks, museums, cafes, and so forth. We defined the methodology based on, you know, those 2 pilots that were done in those 2 particular points. Okay. The first result we realized is that again the academic API has many advantages. Okay, it's good because it allows us to collect more data for sentiment and emotional analysis. Okay, we decided that as a safeguard, because it was just starting, we could continue to collect the stream. Okay. Another problem we had is that, as you know, when you tweet, and if you don't have an XY coordinate, so a geocoded, many of the tweets are not valid. So while those vast amounts of data were a problem, when we are just looking at tweets that are geocoded, the numbers reduce a lot. So this slide here shows the results for each of these cases. So this means that other people like you looking for emotional words regarding life, you can be rest assured that if you collected geocoded tweets, they are still less than 1% of the total tweets. So you can cope with that in terms of harvesting the data and processing it, okay? In terms of the results, it was also interesting to see that depending on how you go, your goals are, if you look just for city coordinates, administrative coordinates, or point coordinates, you can have more or less data. So if you just want to know this for overall cities, you can have, you know, I will say almost 10 times more data. The same with when you harvest data, when you collect data, if you are doing for box data. So again, but when we look at point data, exactly point that tells you which street that a tweet was made, if you look in the 100% data set we have, only 9%, 10% have an exact location per street. So again, we are starting to narrow down the data set that we have, okay? So for Greater London, when you start to link the geocoded location with the tweets that are done, this is also methodologically very interesting, okay? So you can see that, you know, while the geotagged tweets were around 464,000, only 7% of that were geotagged tweets with point coordinates. So again, when you are doing this research, it's very important for you to know if you are really very interested in knowing almost if that tweet was done under a light well or or if it was just at the city level, because you might not need such a refined data set and immediately you get more locations and also more qualitative attributes. So you know if these people like, love, and with them, then you can transfer all those words into the lexicon to know if they are happy and happy, okay? So these are methodological options that for you and all of us working in these areas, it's very important to consider. It took us 2 or 3 months to refine this because of that. The pilots were important, okay, to collect data sets, okay? Accordingly to the word cloud extracted from those tweets during the we can identify those words. And here for in English and Portuguese, you have examples for Lisbon, okay, of what type of words did we find in those tweets. And then, if you remember the methodology I present, with that we can start to convert that into emotions. And because we are using a Canadian lexicon, we then can compare this with other cases around the world where people use the same lexicon. So again, we want to create this transferable methodology that then allows us to move from case to case, okay? So I think I'm now very close to finish, right? So just to show you, so we've been collecting data. Every 15 days we have a look, we see how it's going, if progress. And so what is the ongoing and future work? So we are continuing with data processing, looking at point coordinates data, converting the data into attributes, into words, understanding what is there, seeing what is the age, seeing what is the gender, the profile of the users. We do text mining because again, it's that bottom-up approach. We contrast and compare the two, okay? And then we calculate the sentiment and emotion. Then we link that to other tasks. Like, as I say, the policy to practice, we want to see if indeed there is a match between these emotions and the policies being devised. And then also between academic research and what, this is we are doing. The goal then is to send all these hotspots of emotions to work package 5 that works with neuroscience, and we'll try to match to if what we feel in words, in tweets, matches what all these devices that they are using tell us about what the brain is doing. So we are looking forward very much to see the results, and I'm sure they will present then also their own part of the results. So hopefully in 6 months, we will have, all the conversion to the lexicon, and then from there, to the other work packages too. So if you have questions, I'll be very happy to answer.
Thank you, Elizabeth. I think that this presentation was very interesting also for us. I have to say that it raised a lot of questions in my mind. But anyway, I see that there is a question from Marike.
Yes, hi, thank you very much for a very interesting talk. These are always intriguing data. I was wondering whether you collect time of day that tweets are, because it would be wonderful to see a kind of circadian pattern chronobiology view in these data.
Yes, we do. So not only has an XY coordinate, but has the exact time it was recorded. So if it was at 12:05, it's 12:05. If it was 11:02, it's 11:02. Okay. And obviously in the scope of the project, all these data will be available.
Yes.
So, yeah.
And also, it's all about emotions. Do you also collect data on sleep quality, for instance?
So we collected all data. And that was an interesting question because we thought that this will be just about the day. Initially, we say we collect from when the daylight starts until when it starts. We didn't consider, and then some colleagues that obviously work in, I suspect, similar areas to yours, they were like, no, you need to collect day and night because, health. And so we have the entire range of the day. We don't think we are going to use everything because it's a lot of data, but yes, we have day and night.
Sure, thank you very much. Wonderful data.
Thank you.
Thank you, Marike.
Thank you. Yeah, I would like to make a comment because I think what you are doing is really interesting. I mean, we have used this Twitter analysis in another project, and I think it's very promising. But I think we have been discussing before these kind of tools. Who lives out? No, who are the people that are not using Twitter? Who is the people that is not digitally native? No, so that is always my worry about this, and it's good that you are inferring the demographic of the people that is because I think it's a demographic. Also, I think it's a character thing. No, some people is more prone to make Twitter, to make tweets, and other people no. So I would like to your insight about this, about who is being maybe overrepresented in these kind of maps, and maybe who is left out.
Thank you. Yeah, you are absolutely right. At the moment, we have a problem I'm not a special planner in planning. So we have in one side public consultations where the average age is 60 years old. So because basically if a local authority organizes a master plan and needs to have feedback from the public, most people below 55, 60 years old don't have time to go to a town hall and feedback. And there is no digital platform most of the cases. So we have that age gap where people in their 20s, 30s, 40s, and 50s doesn't contribute in public participation because clearly they don't have the time to go there physically. They need to pick up their children. They are tired. They use that one. At the same time, we have these issues. You know, we can collect feedback from platforms like Twitter, but the average age group is 25, 30 years old. So there is, and also gender, because we suspect there is also a gender bias here, okay, and a minority bias. So there are many reasons. So what we are doing in this case, and just to give you an idea, the average percentage is around 7-8% of a local population. So an average. So it's like for London, for instance. So it's actually not a lot. The problem is that because there is a gap, I think we all benefit to link this platform. So those youths that don't contribute other ways, if we manage to make them contribute in the planning process through Twitter, we all benefit. But we cannot drop traditional approaches because otherwise 60, 70-year-olds won't be there. So how to find the middle ground? Another thing we are doing, and I didn't show here, is that we are still doing not just traditional data set analysis, but also, for instance, for London already collects fine-grained questionnaires regarding some of these subjects, regarding health and well-being. So we are doing this, and we are considering which variables at the moment for the 4 case studies. So again, most of the questionnaires that the metropolitan area does, with luck, depending on the target, is around 10%. But most of them, if it's a census or if it is a local questionnaire, if it reaches 2 or 3%, it's already wonderful, because there is no money in a census to do the entire population. So again, those data sets, even if we try to sample well, cover all the population and so on, we see that they are not enough. So that's why it's almost a must for us to link traditional data sets, new types of questionnaire data sets. And my colleagues, I know that when they are doing the experiment, they will also do local questionnaires. So to the individuals, to make sure that we can cross-reference all of this. But it's a challenge. It's a challenge. I don't think I have a solution.
Thank you both.
Has this solution so far.
Okay, any other question on this? Okay, okay, I think that we are all tired, but let me say that this morning was very interesting, at least for me, because I'm not an expert in lighting design, and I can see that there are a lot of things to take into account. I would like also to invite my colleagues, I see Vera and Mark, if they wish to try to summarize a bit their thought about the work that we have done today.
From my side, at least, is similar to you, Elisa. I'm not expert in lighting. I learned a lot today, and also I realized how many things you have to take into account, new metrics, new approaches. So for that side, I cannot comment a lot. I learned a lot. From more the urban analytics part, I think it's clear what we see today, that the future is about new data, satellite data, cross-sourcing data, and new ways to modeling using intelligence, artificial intelligence, and so on. And also the new challenges that we are going to have regarding this, about participation, inclusiveness, transparency, accuracy. I mean, it's a big way to do it. Still, we cannot, we cannot substitute the old methods. They are necessary, but I think we have a future there that is going to change the way we analyze the cities and the way we understand them. And I think lighting is a real good field to use these models and use these techniques. So, I mean, I'm very grateful for all the presentation because I really enjoy and learn a lot today.
Thank you, Ais. Mark?
Right. Yeah, no, I mean, totally agree. A lot of very interesting presentations. Some went into details that I certainly will not understand in my lifetime. But I think what comes out from at least the first presentations that I we're mostly focused on is basically, yeah, the complexity of urban lighting. So I guess the first part needs to respond to the second part with the data analytics, and how we work on that will probably help us to understand better the complexity of urban lighting. I mean, cities are very complex things. So I think all these individual presentations were really wonderful, and I want to thank the speakers very much for their contribution and at various hours of the day. But in regard to lighting in general, I mean, for the first presentations, I think there's a big question that I'm not sure we will be able to answer now, and not in the future either. But at least we need to try. The balance between the safety and the requirement for more lighting, and the requirement for less lighting to prevent light pollution and biodiversity issues, and also the societal change that perhaps is leading us to accept lower levels of light. And so that's very interesting. And I think all the presentations were well, kind of responding to each other. So we'll need to analyze this in more detail. We touched on private lighting, we touched on dynamic lighting, also which has impacts on how we use the public spaces at night. And I think, yeah, the non-visual aspects are really important for human-centric lighting, and how we light for people. The standards are being challenged, the measures are being challenged. So I think we're on the edge of quite a number of advances, at least, and that for me is quite some hope for the next years. And that's about it for me, I think. Thank you.
Thank you, Mark. Just to say something more. I'm an urban planner, so my main question today was because I think that we have seen that there is a big potential in terms of knowledge and tools. But again, my main question is how to transfer this knowledge to local municipalities, public administrations, because it's not so automatic, at least from my point of view. So I think that the big challenge would be also this one for us in enlightenment, but also in general for those that are working on these topics. And another big question that I have is how to combine what we discussed today, that is more related with the well-being, with the other face of the moon, that is health, conceived with the point of view of the medical part of our project. So we have a lot of material to discuss, I suppose. Okay, I think that we have done a good job today. Thank you all for being here till now, and for comment on what we have seen so far. So now the next appointment is to participate to our plenary session this afternoon. I know that it's Friday, so and Christmas is very close, but anyway, if you would like to spend 1 hour at the end with us to see what has been done in all the other sessions, to try to summarize a bit this important outcomes, you are more than welcome. So please stay with us and see you later. Okay.
And when exactly is the plenary session?
At 3:30.
3:30. Central European time.
Central European time, yes.
Beautiful.
So,
see you later. Thank you. Thank you everyone for being here. It's beautiful to see you all. Thank you.
Bye. Bye.
Bye bye. Bye bye everyone.